In this video, we're going to look at a few applications of linear inequalities. So let's jump into the first one. Let's say we have the base of a triangle is given by a length of 9 feet. So we have the triangle with a base of 9 feet. This is B. And we want to know what must the height be if the area is no more than 20 square feet. And we're given the formula for the area of a triangle as 1/2 base times height. We've seen this before, so we should be familiar with it. So we want to know what must the height be if the area is a maximum of 20 square feet. Okay, so let's go ahead and set up an inequality. On the left side, we're going to have the area, and on the right side, we're going to, on the left side, we're going to have the formula for the area, and on the right side, we're going to have the maximum area. So over here, we're going to have 1/2 times the base, which is 9, times the height, which is what we want to find out. So 1/2 times 9 times h. And we're defining h, obviously, as height, the height of the triangle. All right, so we want to know if the area is no more than 20 square feet, which is going to be on the right side. We want to know over here is going to be all the values that are up to but not exceeding 20. So it can equal 20, but it has to be equal to or less than 20. So less than or equal to 20 is our inequality sign. So we have an inequality that we can solve. So let's go ahead and do so. 9 times 1/2 is 9/2 times h is less than or equal to 20. We can go ahead and solve for h by multiplying the entire inequality by the reciprocal of 9/2, which is 2/9. This term cancels, leaving us with h is less than or equal to 2/9 times 20, which is 40/9. And this is 40/9 feet. This is the length or the maximum height that the triangle can be in order for the triangle to have 20 square feet or less. Can't have any more than 20 square feet, so this is the max height that the triangle can have. And this is approximately 4.5 feet. Not exactly, but if you want a nice round number, there you go. All right, so let's look at another one. We're solving equations using inequalities. So let's take a look at the following application. To watch the local football team play, you can either pay $40 per ticket, so $40 per ticket, or you can pay $250 for season tickets. All right, so this is actually a really useful problem, especially if you're a football fan. So season tickets allow you admission to every single game, where this is paying per game. So, excuse me. At most, we want to know how many games at most can you go to paying $40 per ticket before the cost of season tickets is the cheaper idea. So let's go ahead and label a variable x as the number of games attended. Because, well, at least one side of the inequality, this side is going to be a function of the number of games that you attend. So on this side, we have a cost, and on this side, we have a cost. So the cost of this side is $40 per game, which is 40x, and we want to know at most how many games can you go to before the cost of season tickets is the cheaper idea. So we want to know up to, which means less than or equal to, how many games can you attend before $250 is the cheaper idea. So this is our inequality. We can go ahead and solve for x. So we can divide both sides by 40, which gives us just x on the left-hand side is less than or equal to, we can cancel these zeros on the end, 25/4, or approximately 6, well, it's actually 6.25, but what we're saying here is we can go paying, for each individual ticket, we can attend 6 games before the cost of season tickets is actually cheaper. And this makes sense because if you attend 6 games, we're paying $40 per ticket, that's going to cost you $240. So as long as we're seeing 6 games or less, it's cheaper to buy individual tickets. But once you see that 7th game and once you pay for the 7th ticket, it actually gets a little more expensive. It's going to be $280 instead of $250. So really good to know, especially if you plan on going to any football games anytime soon. Okay, let's look at one more. Let's say your employer can pay you one of two ways. So we're going to have option one, and option two. You're able to pick the way your employer pays you, which is kind of cool. So you can either be paid $1,000 a month, this is called a base salary, plus 7% commission on sales. So this is option one, or you can be paid $1,500 a month. So the option two base salary is $1,500 plus a 6% commission, a 6% commission on sales over $5,000, or sales greater than $5,000. So you can write it like that if you want to use a little inequality symbol that we've learned in this section. We want to know for what amount of sales is the first option better than the second option. And an assumption we're going to make, and it's kind of important, is we're going to assume that sales are always over $5,000. So sales are always greater than $5,000. Okay, so this is pretty important because we only see it over here, so we can actually disregard this. So we have $1,000 per month in base salary plus a 7% commission for option one. Option two is a $1,500 base salary with a 6% commission, and our sales are always going to be over $5,000. All right, so let's go ahead and label a variable t as total sales. Total sales, and everything else is written in dollars, so we're going to write these in dollars too. So total amount of sales, this is going to be our income is a function of the number of sales because we're being paid by a percent of commission per sale. So we have a variable t, and we're going to have two sides to this inequality like always. Side one is going to be our first option, and side two is going to be our second option. And we're going to see how we're going to compare them in a second. So let's switch colors to green because we're talking about money. So option one, here we go. We have 1,000, which is our base salary, plus, let's convert our percent into a decimal, 0.07 t. We're getting 7% times the total sales. And on the second side, on the right side, is option two. We have $1,500 of a base salary plus 0.06, and this is going to be t minus $5,000. All right, this is t minus $5,000 because we're assuming that the sales are always over $5,000, and in option two, we're only getting paid on the sales exceeding $5,000. All right, so that's kind of important. So let's go ahead and compare option one and option two. So the first option, the question we want to know is for what amount of sales is the first option better than the second option? So we can also say this as what amount of t, what values of t make the left side greater than the right side? So what amount of sales make the first option greater than the second option? All right, and this is what we want to find. So let's go ahead and solve this. We have 1,000 plus 0.07 t. We're going to distribute on the right side. So we have 1,500. We're going to distribute this 0.06 into the parentheses, which is going to give us 0.06 t, 0.06 t minus 300. 0.06 times 5,000 is 300. All right, and we can simply, we're actually running out of room here, so let's go ahead and clear some space up here. Oh, not that much. Okay, we just needed a little space. All right, so we can go ahead and combine like terms on the right side. So we have 1,000 plus 0.07 t is greater than 0.06 t, and we can combine 1,500 minus 300 is a plus 1,200. Let's move everything with our variable to the left and everything else to the right, so we can subtract 0.06 t from both sides, 0.06t. And let's go ahead and move 1,000 to the other side as well. So we can subtract both sides by 1,000. These two terms cancel, as do these. So we're going to have on the left-hand side 0.01t is greater than 200. 1,200 minus 1,000 is 200. Let's go ahead and divide both sides by 0.01, which isolates our variable t. These two terms cancel. This gives us t is greater than $20,000. So to answer our question, for what amount of sales is the first option better than the second option? The first option is better than the second option when our sales exceed $20,000. Now this is actually very useful because if you know that you're going to sell more than $5,000 of a particular product every month, we know that option 1 is going to be better if you're going to sell more than $20,000. So if you're not going to sell that much, or you're going to sell in between $5,000 and $20,000, option 2 would actually be a better deal. So this is a good way to pick between a couple options if your employer gives you a few options and see which is the better fit for you, and it'll actually save you a bunch of money if you know how to do the inequalities. So look over this a few times, make sure you understand it, and I'll see you in the next video.